welcome everybody to this webinar this afternoon. And I'm gonna talk about, well, mysteries of Temp-Table and ProDataset parameters. I'm pretty confident that all ABL programmers feel comfortable in using Temp-Tables, but I'm also sure that there are some aspects, especially of passing them around as parameters, may not be known to everybody. At least for me, they are sometimes always, surprising, sometimes confusing again and again. Most of the samples will be dealing with temp tables, but they apply in exactly the same way to ProDatasets, because ProDataset are just a collection of multiple temp tables. Well, quick introduction about myself. I work for consulting work in various roles as a director, as an architect in modernization projects, taking care of our products as well, in various roles there, product manager, architect, very often also developer on our modernization tools like the Smart Component Library or the WinKit. I focus on object-oriented design in the ABL and software architecture in general, working with Progress or OpenEdge now for over 30 years, started in version 5. And try to be quite active in the community and user groups in general. We at Consulting Work, we're an independent IT consulting organization. We focus on OpenEdge and, well, various technologies that have a connection, have a link to OpenEdge. It can be front-end technology like .NET or various web technologies or integration technology or whatever. We're based in Cologne in Germany, with subsidiary in the United Kingdom, in the United States. Peter Judge is joining us from, in Romania, working with customers basically all around the world. We're providing consulting services and developer tooling to our customers. Providing various services. I'm going over these slides quite quickly because there's quite a lot to tell about the temp tables. So this talk today, I'm going to start with an introduction, what temp tables, what they're used to, some aspects about how they're managed, and then start with various parameter scenarios. And in the end, I'm going to compare usage of temp tables with usage of local databases for certain aspects. So what are temp tables? Temp tables are probably the most widely used complex data structure in the ABL. The ABL doesn't offer too many different complex data structures. With the object-oriented extensions, basically we can build our own complex data structures, and other structured data types that we have in the language would be something like a mem pointer, which could be assembling a struct or so. But I think in a classic ABL business application, temp tables is probably the complex data structure that everybody's using. And what are they used for? Well, it could be in reporting scenarios for aggregation of data, maybe building group totals, stuff like that. That data might also be cached in an application for longer than just the execution of a single report. With temp tables and then especially with ProDatasets, the ABL provides a very great foundation for building XML and JSON documents without actually having to worry too much about the XML or JSON syntax itself. And of course, applications that use a client and an app server, basically end-tier ABL applications, typically use temp tables or ProDatasets to serialize application data, so records of customers' orders or whatever, between the app server and the clients in both ways. And I'm pretty sure there are other use cases, but I think those are the main relevant ones. ProDatasets are an extension to temp tables that provide additional functionality to temp tables, like relations between multiple tables, or even between a relation that's recursive on a single table is also possible. They provide a new way of reading data from a database and updating to a database based on a declarative programming style. So you declare where the data should be read from, instead of doing an imperative approach where you barely iterate through database records and populate temp table records one by one. They provide then, as part of this declarative read, a paged mechanism for reading, They provide a mechanism for tracking changes, so a remote client can automatically track which records he updated, created, or deleted in the temp table and sends that back to the app server for processing. It provides mapping of field names between the database and the application, which is also very interesting when you're working with an old style legacy database schema with abbreviated field or table names, so that in the application database model, you could actually use meaningful table and field names. The temp table is only a single entity. ProDatasets by their structure could provide more complex XML and JSON import export. Like I said earlier, my samples here are based on temp tables, but the underlying findings are absolutely valid for ProDatasets as well. So with temp tables, we distinguish two types of temp tables. They could be static, based on the define temp table statement, or dynamic, based on the create temp table statement. Like many other built-in objects in the language, there is the static and the dynamic variant. So the same applies to a temp table. Static temp tables have the huge benefit, and that's something that I'm be covering later. They are always scoped to a compile unit, typically a procedure or a class instance or so. That means when the procedure goes out of scope, the procedure is ended, all the temp tables that are statically defined there are guaranteed to be cleaned up by the language, and with the dynamic ones, we have, as a programmer, have to be more careful that they don't get stuck in the memory. Management of data in temp tables is very, very similar to data in a database. Data is stored in blocks. There's a buffer pool. There's a startup parameter minus capital BT that specifies the number of the blocks in the pool, and there's a block size. Like databases can be created with different block sizes. The temp table storage, which very often is also referred to as a temp table database, can also be organized in blocks of size 1, 4, or 8K. And then we have a block size, the number of blocks parameter for memory cache, and that basically controls how much memory we want to use for storing temp tables. And the simple rule, how do we know that our temp table buffer is large enough? Well, when we look at the file system and we see the DBI file is still growing as the application is executed, then we could probably improve the application performance by making the temp table box bigger. So what are the startup parameters in a table? It's there. We have the BT, the number of the temporary buffers. We have the temp B size parameter, the block size 148 case. We have the minus capital T, the temporary files directory, and the minus lowercase t, which makes temp tables visible. While I was preparing this call, I was actually surprised to learn the fact that on Windows now the temp files are no longer visible by default in the file system. That has always been like that on Linux. And on Windows, that seems to be the case now too. And I tried it on 12.2 and 12.6. So I don't know yet when that really changed. But if you want to look at the file size of the DBI file, then the minus lowercase t startup parameter is really important, because only then you will see the files actually appearing in the minus capital T folder. So what does this minus BT and temp B size parameters mean? They define an amount of memory. The minus BT, the minimum value is 10 and the maximum value is 50,000. The temp table block size can be 1, 4, or 8K. The default value is 4K. And if you multiply 8K by 50,000, so that's 400 megabytes of memory. And then you have to apply a factor of 1.1. So 440 megabytes of memory is a maximum that a single ABL runtime session can use for temp tables. I assume that the value of 50,000 is just a randomly chosen value. I don't think that's a technical limitation that Progress couldn't increase, but yeah, that is the range that we have. And we'll see very, very soon what impact it makes to the runtime performance when you use a larger or smaller temp table buffer. Well, memory may be a limit on a system, and as temp tables for many people are used on app servers too. Here, what it means for a PaaS-OE. On the PaaS-OE, the multi-session agent, the memory used for temp tables is per session. So on a development system, the default number of sessions per agent is 2. So when you set minus BT to 10 with an 8K block size, then the every agent session requires 45 megabytes of memory for the temp tables times 2 sessions. And if you go up to 50,000, then you see you have the value of 452 megabytes per session. And that can accumulate to a quite significant amount of memory. And we can see that in the task manager. So here I start my PaaS-OE with the maximum memory I can have for temp tables, so minus BT 50,000 with an 8K block size. And I see that right from the start, the PaaS-OE hasn't done anything. The memory consumption of the single PaaS-OE agent is already close to 1 gigabyte. If I go with a smaller value, 10, then I see my PaaS-OE is less memory hungry. It goes with 110 megabytes. And if I use the OE manager to look into the individual sessions within the multi-session agent, then you see that in one case, we have the 450 megabytes. And in this case, we have the 45 megabytes. And while I was creating the slides, I also had to count a couple of times the digits of the numbers because they both start with 4. It looks like the same value, but there's actually a power of 10 in between them. There are a couple of other parameters that have something to do with temp tables -z/ds reuse. Probably the minority of you is still on OpenEdge 12.1. That was a startup parameter that in 12.1 enabled objects that use temp tables and ProDatasets in the reusable objects cache. From 12.2 on. That is the default value, and only if you would have had issues with that, you would use ZDS reuse to turn that feature off. No check TT names as a parameter that relaxes the requirements that temp table parameters in the sending and the receiving program need to have the same field names. Check is limited to just the data type and extent and similar properties. And when you're using a Progress GUI client or a Progress Open client connected to an app server, the TT Marshall startup parameter can be used to control how much schema information like field labels, like help text, etc. you want to send across the app server whenever you're sending a temp table back and forth. Then there are startup parameters that are related to the temp table VSTs. They're very similar to the startup parameters that you'd be using on a database server for monitoring access to individual database tables and indexes. So there's the TT base index, TT base table that controls how many temp tables you really want to be able to monitor. This monitoring of the access to temp tables includes things like counting how many records you've read, how many records you've deleted, the size of the temp table, etc. That is nice for monitoring purposes, consumes a lot of memory. You would, or you have the ability to select these parameters so that you only monitor a small amount of your temp tables. There's a knowledge base entry that describes it all in great detail. I'm not going to cover these features today because that would probably be a great subject for a future webinar by itself. So let's start with a very simple program. This program defines a temp table like the customer database table and adds a single index. The define temp table statement with a like option. When you specify a single index, only use that index. If you do not specify an index, then all the indexes of the database table would also be inherited to the temp table definition. And what I do is I count the, I iterate all my customer records. My Sports 2000 database here has around about 200,000 customer records, and each of them I copy in the temp table, and I count that. I count the time, and then I have in the end for each TT customer by customer.name, which here is an unindexed field. And so I was running this program with various combinations of BT and temp TMPB size. And by that already I was a little bit surprised by the results. But what we can clearly see is that a small minus BT means that I have the longest runtime for populating the temp table. Why that? Because I will have to start writing the temp table to disk fairly soon. The DBI file size at the end of running it with the minus BT10 is 41.4 megabytes. So that is just a very easy way, if you do that with just one program, to see that this is what the temp table needs in memory. I can neglect the 10 1K blocks that are still in memory, because the majority of this temp table has been written to disk by that time. So what then happens with this program is basically I load 200,000 records one at a time from the database. My database has a database buffer pool which is large enough to hold the whole database. So that's basically a reading from memory, but I write the data actually to disk. And I can see in the second line or in the last line, if I make my temp table buffer pool large enough, then the DBI file will not be touched. The size will actually be 32K on file system, but that's just the initial size. And the result is that I save 1.3 seconds. So I basically save roughly a third of the runtime. And the unindexed for each by the name field also gets faster. It gets faster by the number of buffers, not so much by the block size. The block size has some influence on the write performance, but not so much on the read performance. And that's basically expected, even though when the size of the numbers are a little bit confusing. So now we do an alternative temp table definition. I leave out the single index and I just do a like definition. Like many lazy programmers do, we just do our temp tables like the database table, and we don't care about whether or not indexes are used. And the results of that running with the same startup parameter configurations were quite confusing, to be honest. And I discussed it also with quite experienced developers. I had that discussion with Peter Judge, I had it with Tom Bascom, and the values that I got were quite confusing. And I'm gonna offer this as a guesstimate game to all of you. So we've seen the numbers on the slide before for creating the 200,000 records in the temp table with just the index by the customer number. Now I'm going to do the same with 5 indexes. So it's the index by customer number, the index by name, it's the index by country and postal code, one index by sales rep, and a word index by the comments field. I think the expectation, what gets faster and what gets slower, is easy. The read operation will be faster because now we have an index by the name field. It would be really shocking if that wouldn't be true. And the other thing that is probably expected is that the population of the temp table becomes slower because there are more indexes that need to be populated. But by which ratio? Are we talking about a 10% performance decrease, 50% performance decrease? Is it getting 2 times slower or 10 times slower? So if somebody wants to make a guess. Yeah, Peter sends me a message. Yes, it's on the right performance that we should be making the guess. So Wim says 2 times. Any other guess? Don't be shy. Well, it is roughly 8 times. So Harrison is then closer. And the fact that it's 8 times was really shocking. I mean, I'm using almost no memory, so there's a lot of write to the disk. And for sorting the indexes, that means we have to read from disk while we're sorting the indexes. Here's the output of my test program. I see the number of indexes is confirmed for this test case. It's a case with a 5. The creating of the records is here in the range of 25 seconds. I usually do 3 runs and then average them. And it did create these 201,000 temp table records. The iteration by the customer name field is 1.8 seconds, roughly in average. And if I put that into the table before, then we see that now that we add 4 extra indexes, first we see our DPI file gets bigger from 41.4 megabytes to almost by 5 megabytes bigger, so 10% more memory needed, either in RAM or on disk. The populating that was before 3.3 seconds now are 25 seconds. The for each by name is a little bit faster. And the total runtime then of this program is was 5.4 seconds, now it's 26.8 seconds. If we use the case with the large minus b, then we see the populating is still slower. So that went from 2 seconds to 3.8. So that's still almost doubled. So that is in the range that Wim guessed. Reading the data is as expected faster, so that went from 0.5 to 0.2 seconds. But the overall runtime of the program went from 2.5 to 4 seconds. So this is an example where we see that indexes on a temp table have a probably very surprising impact on the runtime performance. In short, in this program where populates the temp table once and then I process it once, I was always faster without the indexes, or with a single index versus all the indexes. When we made the temp table buffer bigger, the difference got less, but it was still noticeable. And why do I think this program is quite relevant? It is for a lot of classic use cases where the app service used to retrieve data. That's exactly what's happening. We are loading data from a database, putting it into temp tables for a very short time, and then ordered by a specified field, we are either exporting it to JSON, XML, or returning it to a GUI client. Even though this is a very simplistic sample, it drills down to what very often happens with temp tables in app server-based applications. So conclusion is, be careful with indexes you add on a temp table. I mean, I could also say, be sure that you only add the fields to the temp table that you need, because the fewer fields you have, the less space you would also need. But indexes is something which probably it's more often that you never use them. Especially word indexes are quite expensive, and word indexes are very useful in a database to select only a few amount of records from the database into the temp table. But once the data is in the temp table, I think it's very unlikely that you'd ever be using the word index. So populating the word index just because the like definition is the laziest way of doing it is gonna cost you a lot of memory. So as a rule of thumb, only define a primary unique key index on the temp table, and other indexes only when you really know that you're going to be using them quite frequently. If you do one unindexed iteration of the table, it is going to be faster to do that on the fly, because creating the index and doing the unindexed sort on the fly are very similar operations. The difference just that the index actually has to be written on disk and requires additional management there. So be careful with like definitions and indexes in general. So now let's look at using temp tables as parameters. So simple statement, the temp table can be passed from one program to another one as a parameter. By default, the AVM, the AVL runtime, always passes temp tables by values. That means a deep copy, record by record, index entry by index entry are passed from program A to program B. There's some requirements for the schema to be similar enough. Not all the options of the defined temp table need to be the same, but field names, data types, extents, things like that need to be the same. I don't think the format needs to be the same. The labels do not need to be the same, but really everything which defines the data type. And if you want to relax it a little bit more, you can use a no check TT names starter parameter. So how does it look like? Well, we have a program that has its own temp table TT customer and passes that to another program that defines the same temp table. And then we define input parameter for table. And similar logic would be possible for classes too. I'm not using classes here because that would maybe have all my programming samples twice. So when we run this program and add some logging to it for the size of the DBI file, then we see two things. We see that the initial population of that temp table, in this case with whatever starter parameter I used there, took 3.8 seconds, roughly. The DBI file was then 41.4 megabytes big. So that was the first program that populated its own temp table. And then it started the other program. And calling that did cost almost the same time as the initial population of the temp table, so 3.2 seconds. And the DBI file was a little bit more than doubled. There may be some rounding differences there in expressing it in megabytes. So we see that for the time that the second program is executed, we need twice the memory for the temp table because it is there twice. And what we also observe then is the DBI file never shrinks. It's like Progress database files, they just grow. And once they've reached a certain size, they keep that size because even when the space is currently no longer needed, but extending the file size is something that would be a relatively costly operation. So OpenEdge only extends the files in the one direction and doesn't shrink them. So now we do that with an input-output table. So we have our own temp table, we populate that, we pass that to another program, and with the input-output, we are expecting output back from the caller. What does that mean then in runtime? It means the same in memory. The DBI file size is the same. So that means on the way from the first program to the second, we duplicate the table. That's why the DBI file grows to 82.9 here. On the way back, it seems that the table which is in the first program is getting replaced. That's the nature of the output parameter there. But that does not require the DBI file to grow. That was one where I was uncertain whether I would actually be seeing for a brief moment in time the temp table 3 times in memory, but it's only twice, so that's good. But what we see is that it has a big impact on the runtime. So I populate the temp table. I'm in the range of 3.6 seconds there. And the numbers vary a little bit based on wind pressure and temperature outside or whatever. But the calling, which here means I run that program with input-output and I return, are now 6 seconds. That was 3.2 seconds earlier. So here I see that getting the 200,000 records back actually also means a lot of runtime. And these things are noticeable in real-world applications. Usually, probably not so often passing around 200,000 temp table records, but the times for passing around temp tables is something that in many, many programs has a huge impact on the runtime performance. Another thing to notice about temp tables when being passed around of parameters is that you cannot rely on raw IDs to locate records. So I have a program that starts then the callee and gets the data back. So that's actually the program that I had earlier with the input-output parameter. And I do at 3 different locations in this flow a find customer where ttcustomer.custom equals 1. It's a unique index, so I can do that, and I just output the raw ID. And we see that initially in the caller, the row ID is 120. In the callee, the row ID is 15B920. And when I get it back, it's 220. And why that? Because a row ID is not something like a record number in a table or whatsoever. A row ID is specifying the location of a record in the database. In this case, it's the Temp-Table database. It's a DBI file. So the row ID is a combination of the block number and the record number in that block. And so when I pass the Temp-Table from A to B, it's natural that the Temp-Table is the whole Temp-Table is duplicated. So the record customer number 1 is at a different location. And when I get back, it is also a different location, which, well, could also have been accidentally the same, but it is actually no longer the same record. It's just another customer record that has the same field values, and therefore it has a different location. So that means if you are located at a certain record, you call another program with the input-output table and you return, and you want to fetch the same record again from the temp table, you cannot rely on row IDs. Row IDs are pretty stable in databases, but in temp tables you cannot trust them. So that means you need actual primary key field values of a record to be able to fetch the same record again after one of these operations. Yeah, so in short, that is really a pledge for primary key in every temp table. And while we're at it, I also believe that every database table should have a primary key. And I know many customers' application databases that have quite a few database tables without primary keys. And I think that's something that always just causes more problems than it actually helps. So how can we improve that? Well, one option is to add the by reference option at the caller. When calling the second program, the callee, when you're passing the table, you can add the by reference keyword there. And what that means is behind the scenes, we don't really see that. Then instead of duplicating the temp table record by record, a handle is passed and the receiving program will then overload its own temp table, which is referred by the receiving parameter with the temp table it passes. It's all happening behind the scene magic in the AVM. And that solves both problems. It solves the DBI file growth, and it also solves the row ID change, because I'm actually passing a reference to the same set of records and I'm not creating a new set of records. This sometimes can lead to challenges in the receiving program, because the receiving program does not know whether it is actually working in an internal procedure, for instance, with its own temp table or with a temp table that it has received by reference. The by reference keyword is only specified on the caller, but not in the program that you call. That sometimes, yeah, may lead to things. I've a sample program that I will show in a second, where you would actually be returning no records because you prepared them in the main block of a procedure, and you're getting them from an internal procedure by reference, and the data that in the main block has been prepared is just not accessible while you're calling into an internal procedure with by reference, for instance. So you cannot enforce calling or getting called with by reference, or you can also not enforce not getting called with by reference, but you can find it out. There's a property on the temp table object handle called num references, which if you are getting it by reference and the number of references is 1 or larger, depending on how many other programs have a reference to exactly that same temp table. If you're working with your own temp table that nobody has a reference to, then number of references returns 0. So what does that lead to if I have a program that's called like this, that defines its temp table TT customer? In the main block, I'm outputting the name of the procedure that has created this temp table. It should actually not be this procedure. That should be the instantiating procedure of the temp table. That's a mistake on this sample. And I output the handle of the temp table and the number of references, and then I have an internal procedure with a temp table parameter that could be called them from the outside. Then we see that we are actually dealing with different temp table handle numbers. So that's also a way how we could be seeing that we are working not on our own temp table, but on the temp table that we've received. The num references attribute here as part of the message that we've seen in the sample, while I'm within the internal procedures called from a simple callee program, we see the num references. And I think that's something which I would be showing in the full source code to make that clear. That's the TT param start by reference. I do have in the outer program a temp table defined, and then I start a procedure persistently, which executes the main block. Then I start an internal procedure and I pass the temp table by reference, and in that callee, we then see that the main block and the internal procedure basically do the same output, but the result will be different handles of the temp table. If I execute them without the by reference option, then the temp table handle value will be the same, because then by calling into the internal procedure, I'm copying the data of the caller into this into this temp table and returning data from there, but the handle of the temp table is always the same. So with the by reference option, the handle gets potentially or will get a different value. Input and output with by reference is very confusing. Basically, by reference is always input. You can specify output with by reference, but it is input. What happens is the temp table passed by reference the caller is passing the handle to its callee. The direction is really irrelevant. There's a case where it becomes relevant, but that's in combination with the table handle parameter. And when the calling program does not have a handle yet, then it could be receiving the handle of the callee. And those are then really cases where, in order to know who is working on whose temp table, where it really helps to draw a flow diagram and see who's calling whom when and with which option for the table parameters. What this program here does, that shows the challenge as well. So I start the program persistently. The program is here on the bottom right. When I started persistently, the main block is executed, which populates data in this temp table. Nice. Then I run the internal procedure, output table by reference, which if I would not be doing by reference, it would be returning me the data which is in that persistent procedure. But since I'm doing by reference, I'm actually getting no data back because the internal procedure does not add any data. So the data that I send in is actually the data that I had before, and I don't see any data that I created here before. So my number of records here would be 0. And that completely changes with the use of the by reference keyword. So while the by reference keyword does many, many great things for performance and the memory consumption of temp tables, it completely flips the the passing of the data around potentially. So something to be very careful with. There's
Sorry,
no,
Mike.
yeah.
Sorry, just on that previous one, just to note, or a question, I suppose, is if you have an output table, can you, in that case, so if you could go to the previous slide, oops, sorry, the one you were just on, the output, can you tell, there we go. Can you tell in internal procedure that you're being called by reference? So,
well, you can in the internal procedure by checking the num references of the TT customer. If the num reference is 0, then you're not called by reference. If it's 1, you're very likely called by reference. And I have to say it with a certain uncertainty, because the num reference could also be if you have passed your reference to somebody else earlier, then num reference is also greater than 1 if you're not being called by a reference. So the safest way would actually be to keeping track of your temp table handle in a procedure on the main block and comparing the temp table handle in the internal procedure. Then you really know whether or not it's your or somebody else's temp table that you're working on. What we do when we have temp tables where we expect that they're passed by reference, we document that in the parameter documentation for that procedure or method of an object. So one way that can help, both with a little bit of memory, but also with enforcing by reference passing, is to define temp tables with the reference only option. When you define a temp table with the reference only option, then the compiler still knows the schema. So you can do a static for each. The compiler can validate all fields and do index selection, whatever, on that temp table. But when the program is started, no temp table instance will be created. When there's no temp table instance, then well, there must be a little bit memories that we save on that one. And then this temp table can only be used for by reference parameters from somebody else, or bind. I'll talk about bind later. And when you try to access the temp table before you receive the reference from somebody else, so before it's being passed as a by reference parameter, then the ABL runtime will pass an error. So like this, I have a definition here with a reference only keyword, and then I try to do the for each on that and on the database table and create records. Then I get this error message: attempt to reference an uninitialized temp table. So that means a reference only definition, and I haven't received a reference from somebody else yet. Well, if it's used as a parameter and you call then the procedure, the internal procedure without the by reference keyword, then you get a similar error message. Bind or by reference modifiers required on the run functional method invocation parameter when called table is reference only and not yet bound to something. So the error messages you get are surprisingly clear. Good. So let's look at bind. By reference is a way of getting somebody else's reference into your temp table definition. The nature of by reference is always of a temporary nature. By reference only applies for while you're executing a single procedure, and that procedure must be getting the table by reference. Bind is similar, but it is providing a permanent coupling between multiple procedures and a temp table. And with bind, tada, with bind input or output can have a different meaning, or do have a different meaning. Bind also requires that the receiving temp table definition must be reference only. Whenever I look at the differences between bind and by reference in the syntax, I mean, conceptually they do the same, but Conceptually, the only difference is the one thing is for a short period of time, the other one is permanently. But if you look at the syntax support, the syntax of the bind is much, much clearer. Bind must be specified on the caller and the called procedure. Bind must be reference only. So if you ask me, the inventors of the ABL have come to the conclusion that with by reference, they have just caused lots of confusion, and they want to make it much better with bind. I think that was quite well. Bind also provides a couple of error messages when it's not done on a reference-only temp table, or when you use the bind keyword only on the parameter definition or on the call, then you get one of these error messages complaining about invalid use of bind. So how do we, one example how we can use bind. So on the left-hand side, I have the program that calls the program on the right-hand side. The program on the left-hand side defines its own TT customer reference only, so it cannot use it. It then starts the callee persistently, and then calls into an internal procedure, and then uses the output table TT customer bind, and that internal procedure there defines the output parameter table for TT customer also with the bind option. So bind is on both ends there. We see that the main block of that persistent procedure populates the temp table, and from that run of the bind table procedure, so the line that receives the black arrow, thereon the program on the left-hand side is referencing to the same instance of the TT customer temp table as a program on the right-hand side. So that's now the permanent binding of these two. And that also works the other way around. So now the program on the left-hand side, the caller, defines the temp table without the reference-only option, so it really has a temp table instance. It now calls the program on the right-hand side persistently, and now runs the bind temp table with the input option. So I do not specify input on the left-hand side, but we all know that on parameters, input is a default. And on the program on the right-hand side, the internal procedure bind table now gets an input parameter table for TT customer bind. So now the program on the right-hand side, which is launched by the program left-hand side, basically borrows the temp table or shares the temp table with the program on the left-hand side. The owner of the temp table is still the program on the left-hand side, but I can then call internal procedures like what I do on the last line on the left-hand side. I run the count records procedure, and that is just doing a query on the TT customer temp table. I do not need to pass TT customer as a parameter for every call. These two programs are now working on the same instance of TT customer for as long as they are both there. Bind is permanent. There's no way to rebind to another definition. So here, if I would call a persistent procedure 2 times into 2 different handles, and I try to bind it in the second line to the temp table from the first persistent procedure, that succeeds. But when in the last line I run bind temp table on the second instance of the temp table, I would get the error message there. Bind is used when the caller temp table is already bound, and TT customer is also bound, which means TT customer is at that point itself a valid definition in the call programmer. Then that's only possible if it's the same instance. So you can just run the bind again if you'd be binding to the same thing. It's like eternal marriage without an option for divorce, and you can only marriage the same temp table again. And what is quite surprising, bind survives deleting the temp table that owns it. So in this case, what I'm doing here on the program there, I'm calling a persistent procedure. I'm binding to the temp table TT customer in that persistent procedure, and then I delete that procedure. I message valid object of H procedure. That is just to confirm that the temp table that the procedure H procedure is no longer there. And the 2 statements at the bottom, find first TT customer and message TT customer.name will return data. So if I bind to that temp table definition, that means the program that has the defined temp table without the reference only is already gone. And it would have been my expectation that with that the temp table would also be gone, so that the bind would be somehow broken. But that's not the case. The bind survives that. So the temp table is for the ABL now probably good way to say that would be it is equally owned by both parties. And so if one party gets deleted, there's still another party that owns this temp table, and the Progress runtime will only delete that temp table when both parties that are bound to it are gone. And now, while I said that I'm not going to use object-oriented programming in this sample, I'm going to show a small class. One thing that we can use with a very simple ABL class is now to basically simplify the whole parameter passing and who owns which temp table and when do we have by reference and bind and when is it input and output by the user and object. It gets easier with objects because with objects we know it's always by reference. There is no by value passing of objects in the ABL unless we're passing objects across the AppServer boundary. By reference is generally very efficient. And now we can create an object that basically just wraps a temp table definition. So and all that is in this object is this. I define the temp table. And I have a single public method bind table that provides the TT customer as an output parameter bind. So now can I use this, for instance, now I have on the top left a program that creates now an instance of this customer temp table holder and then calls the bind table method of that object instance with the output table TT customer bind. I have skipped the temp table definition on the left-hand program because it's the same as on the right bottom program. Then I can populate the temp table, and I'm actually populating the temp table that initially was created by this holder object. And then I'm running another procedure persistently, and I pass the reference to the object. And I don't need to care about reference only or I don't need to care about by reference or bind or input output or anything. I just pass the object reference. And on the right-hand side and the bottom, I see then inside this program, I'm basically doing the same. I'm calling the bind table method of that object so that I get access to that temp table, and then I can run a query against it and count the records. So that's a way how we can use an object to simplify passing temp tables around. And well, seen in all my programs, I was using the temp table definition always in the programs there. In our real world programs, what we usually do is we have temp table definition in include file. I know a lot of programmers are quite negative against include files, the use of include files, because I think it's a construct of very old programming languages. But I still believe that, especially for defining temp tables and data sets as shared data types, the include file is the best solution for that. And what we do is we have the reference only as an argument to the include file, so that we could have an include file reference just for ttcustomer.i that defines the temp table without the reference only option. And if we want to pass a reference only, then we use the named reference only parameter, saying reference only equals reference only. Good. Now come table handle parameters. And I very often hear from programmers and saying like, well, aren't they much simpler than table parameters because they're just like passing around handles? And I think the opposite is true. A table handle is not passing around a handle of a temp table. The table handle parameter by default is also a by value deep copy, record by record, index entry by index entry of a temp table to or from a callee. And the same rules apply regarding by reference and bind. So it doesn't simply simplify anything, but there's some things that get more complicated with table handle parameters. The one use case for table handle parameters is they are needed when at compile time you do not know the schema yet. And I think in business logic, so what an application programmer would be writing day in, day out, they have very rare use cases. Typically, table handle parameters, they should be used in flexible interface code or APIs, so like the procedures on the app server that get all your calls or something like that. Typically framework code, but I would never like to be coding in a customer report a dynamic reference to the custom field, seeing something like Temp-Table : custom, whereas all the validation, whether the custom field exists and if it's the right data type, etc., is only done at runtime. I would like to see that at compile time. So table handle is really something that should be used very, very careful. Table and table handle parameters are compatible with each other. So a program can be passing a table to a program receiving a table handle and vice versa. And the only requirement there is that the types of the fields, basically the schema matches. So let's look at this program here. So I'm now iterating 5 times, and I've now saved the usual population of the temp table with my 200,000 records here. So I'm iterating 5 times. I'm taking the time. I'm running the program that expects a table handle parameter. So I pass my TT customer into that table handle parameter, and then I'm doing a dynamic query to count the records. So and if I look at what's happening with this program, I'm seeing before I start this 5 iterations, my DBI file is 35 megabytes. So that's like 1 times the temp table. After 1 iteration, it's 70, then 105, 140, 175, 210 megabytes. So it looks like my temp table is now suddenly 6 times in memory. I see the runtime for each call is 1.4 seconds. So I see that it's not something like passing a handle around the table handle parameter, and then go back to the program. Obviously, does a deep copy of the temp table, and it's obviously also quite expensive because my memory grows and grows and grows. One thing that now can help to inspect this is the client log file. So I have enabled in my sample here the log entry types for the dynobjects.db that includes temp tables and queries and so on, and the 4GL trace. And before the program exits, I've added log manager : close log. And when Peter and I have been discussing about these slides, we realized that there's a documentation bug in the Progress Developer Studio online help for the log manager entry. There is a separate log entry type for temp tables called temp-handles, which makes some things which are also shown in the objects.db more obvious. Yeah, you get it from the dynobjects too. In the PDF documentation, no, is it still PDF? In the documentation website, the temp tables entry type is shown, but not in the online help. So that's what we see with the dynobjects log entry type. So what I see in this program is I see that whenever I call this program, so whenever I see a run tth param call lee.p, a TT customer is being passed, and that creates the temp table and the default buffer for that temp table in the session widget pool. Then my program creates a query in line 27, and I delete the query explicitly in line 36. And I see that the same happens for all the iterations. What I do not see is I do not see anything deleting the temp tables. So now that we have this log and this client log with the dynobjects logging, This knowledge base entry there shows details and also contains a sample program, the findleaks.p, that basically uses the client log file as an input and returns a report telling where we are leaking objects. And that program would now telling us that we're leaking 5 times the temp table object. That helps with fixing these issues quite well. So how can we fix this? Option 1 would be deleting the temp table. So I've added if valid handle h-table and h-table num references equals 0, then delete object h-table. The result is we will only see the DBI file growing once because the sender has the 35 megabytes temp table and the receiving program creates a 35 megabytes temp table. But before the program is exited, we're deleting that object. Great. So I'm seeing it once going from 35 to 70 megabytes in the DBI file. My runtime is still close to 1.4 seconds each time. So option B is to use the by reference on the caller together then with the parameter which inside the callee is a table handle parameter. So then no deep copy is being made. So that also means there's nothing to be deleted. But still in the called program, I would contain this if valid handle h-table and h-table num reference equals 0, then delete object h-table, because I have no easy way to enforce that my program should only be called with the by reference temp table. So I should be prepared for both situations. So that was the input situation. Well, let's first look at the result. We see my runtime is quite fast. The DBI file doesn't grow at all because I always work with the same instance of the temp table. There's another thing that could be happening with this is if we're no longer working with individual temp tables that we're passing back and forth. These kind of situations may lead to situations where you're expecting to be working with an empty temp table, but you're actually getting a reference to a populated temp table. So you may have to do an emptying of the temp table in those cases where you need to work with an empty. Good, let's talk about the output table handle parameters. A typical use case could be like a dispatcher procedure, like the one procedure that accepts all the read requests on an app server. And as the arguments, I'm passing some form of a procedure name or an object name, whatever, and I'm returning here a table handle. And the reason why I work with a table handle here is because this dispatcher program should be able to pass through various types of temp tables. It should be able to pass through the customer, the order, the sales rep temp tables. And it runs then another procedure and it gets the output table handle from there. So if I run this, I see again in the client log file, this time at line 30, and I would be seeing that line 30 is actually the run statement where I get my output temp table, that a temp table object is dynamically being created and a handle is being created. And we see in this log file also that they are not deleted anywhere. So how can we fix that? One way of fixing that is also adding the delete temp table statement. And I can show that program. Here. So this is a program that's being executed. I have my output parameter h-table. Here it's getting populated. And before the program exits, I delete the temp table. And this really always, whenever I see this, I could start crying because when I read the code from top to bottom, I'm deleting h-table before it's being returned. But the AVM, the AVL runtime, defers the deletion of the temp table object handle until the program is finished. So that's, again, happening behind the scenes, nothing we can influence, something that we need to know. And now if I do this, what I see is the temp table grows once. In this case, now I have the temp table once in the first caller and then the second caller, and it would be in the middle program once too. And how can I improve this? Well, again, whenever I pass the temp tables around here, I use the by reference keyword. Where was my, oh, there was one. The other way would be using the by reference keyword. And I also here I use it in combination with still deleting it when num references is greater than 0. And now I see it's again just one instance, one copy of the temp table. So if I look at the call details, first program starts this TTH dispatcher.p with an output table by reference now that's being returned from the table handle output parameter. And that dispatcher program calls the actual callee program with the table handle on its side and a table within the call program. And this has a nice side effect because now actually the temp table from the first program, ttparent start, which calls the dispatcher, is being passed into the dispatcher. And from the dispatcher, even though it's output parameter table handle, but because it's all by reference, it's actually in input. When the dispatcher calls the final callee, the tth-parent callee.p, the schema compatibility is verified on the run before anything happened within that program. If we wouldn't use the by references there, then the schema would only be checked when we return to the first program. Since it's always nice to fail early, this way also provides the input of failing early if we have conflicting temp table schemata. Good. So coming to my end, couple more slides. Some thoughts about temp tables and local databases. Temp tables and local databases, so a database on the same machine, or generally databases, are organized very similar with this block-wise storing of records. Records are stored in blocks. Records are referenced by a record number in the blocks. Records may be stored in multiple blocks. We have a similar caching mechanism with -B and -BT and block sizes. And I think it's no wonder why the Progress documentation here and there references to the DBI file as a temp table database. If you measure read performance of data in a local database connected via shared memory and data in temp tables, you will see that it is very, very similar. The differences are really in the usual deviations, depending on air pressure, depending on whether it's the same time you're getting an email and whatever. It is very, very close. So that means getting data out of a local database connected via shared memory is not into a temp table, is not automatically making things faster. We now have options to think about where we spend our, or for what we spend the memory that we have. So whether we think it's better to have memory spent for the -B of a local database or for -BT on a temp table database. And that depends on what the data is being used for. So temp tables are typically of temporary nature. They should be of temporary nature. That should be the data that we're passing, that we're reading from the database, doing a little bit of processing and then returning it to a client, or maybe a short-term aggregation of some application data. Databases, the nature of databases, they're persistent, they're persisted, not in the database, on the file system. The Progress AppServer has no mechanism to share temp tables between AppServer agents or PASOE sessions. I've heard years ago, around the time of OpenH 10, when OpenH 11 was being planned, there were thoughts about shared agent temp tables, etc. but that has never been implemented. I could only assume that Progress came to the conclusion that using a local database instead provides much of the same benefits for much less development cost for Progress. What are the benefits of Temp-Tables then if it's not the performance, while the management of the schema? I mean, there's no need to deploy delta df files or df files into Temp-Tables. They're coming with the programs and are dynamically being allocated. But on the other end, with databases, there are much more tuning options. You have private buffers that can help managing the buffer pool better. You can have multiple storage areas. You can spread data on different disks. With the Temp-Tables, there's only one -t parameter, one directory, one file system. You can use APWs, BRWs, and whatever. I'm not the best database tuner in the world to list all of the database tuning options. But there is just more tooling available to make databases perform great compared to Temp-Tables. The other thing is the buffer pool for databases is only limited by the physical memories that we have. The buffer pool for Temp-Tables is limited to 50,000 blocks, which is then a maximum of 440 megabytes. So there's a limit there. Plus the database buffer could be shared by multiple AppServer agents. So that means if you're using Temp-Tables for long-term caching of application data, it is actually worth to consider databases as an alternative to that. So use a cache database, which is running on the machine where the AppServer is. This caching of data in Temp-Tables, well, when is it typically done? Well, when is it useful? When the database is not on the same machine as a PAS-OE, because then the Temp-Table as a local database is typically faster than a database connected via TCP/IP. And there should be a large degree of aggregation. So some examples could be like security data in the maintenance table of security data. Security might be defined against user groups. Users could be in multiple user groups. User groups could be nested in other user groups, so that you may need quite a few read requests to know whether users allowed to do a certain functionality. And if you do that very often, it might make sense to flatten that in a Temp-Table. Translation might be a similar thing. If you want to translate certain data, you might have to look at for strings or messages in various languages to see where you have it available, stuff like that. That's data that typically is not really of temporary nature. For me, temporary nature would be a matter of seconds. That's data that could be could be around for hours or days or weeks or whatever before it changes. So this kind of data might be worthwhile to be put into a database. So local cache database, because the benefit is the local cache database then can be shared by all your AppServer agents or the PAS-OE sessions, whereas Temp-Tables are only used by a single AppServer agent or a single PAS-OE session. So you might end up having the same data 50 times around if you have an AppServer agent, a classic AppServer with 50 agents. And that's actually quite expensive. You would need 50 times the minus capital BT Temp-Table buffer. It would be writing to 50 DBI files, etc. Whereas with a database, you would only have all these resources required once. And yeah, well, the price for that is that the database and the schema update of the database and the question for how long would the cache be valid, and maybe also updating the cache, all that is more costly than if it's a database. But it allows you to achieve much better runtime performance. And so Temp-Tables really should be temporary in nature, so short living data. That's what temp tables are really good for, and that's what you need for them for. And for short-living data, it wouldn't make sense to write that into a database. So, and with these statements here, I'm typically focusing then on the app server. The story with the GUI client is typically different because the GUI client is typically more remote from the database, not running on the same machine. Terminal server could be a different story there, but typically when GUI clients are really distributed, then that's true. So, and I'm having the statement may there because it really depends on the use cases, but there are many caching scenarios where database tables will be a better solution, maybe a better solution than temp tables. So like with all features in the language or with all, well, with many things in the world, as you start overusing them, that may not be the best option. Good. With that, I'm coming to my end, and I would open it for questions.
Yeah, so there's some commentary in the myself one as well. There's some commentary in the chat around caching data in a local database, but no real questions yet. So if anyone has any questions, now is the time to pop up. If you want to unmute yourself or show yourself or put a question in the chat, all are good methods.
And if not, don't hesitate to email us later. We'll make the slides and the recording available. And yeah, if you have questions, we'll try to answer them as good as we can. So Wim had a question, how can I force a temp table in PaaS-OE to become permanent in a session? Well, Wim, that requires two ways. If you're writing object-oriented code, a simple method would be you have a class with only static methods, and you define the temp table with the static keyword. Then that is there in the static class. That's the easiest way to keep it around forever. And then you can bind to it. If you do not want to use static objects for that, and I would really suggest not to use static classes for anything that manages data, then you should look at something like the service manager that's described in the CCS specifications as a means of providing an object, a service object that has the purpose of keeping that temp table around. On the GitHub page from Consulting Work, we have a sample, and yeah, I wouldn't suggest that we use the create temp table for dynamic temp table. That would be another option.
Dirtiest way possible, right?
It's a dirtier way, and yeah, but generally when PaaS-OE doesn't behave, the PaaS-OE session doesn't behave in any way different than a Progress GUI, TTY, or batch client. It's an ABL runtime session, and all the dirty or less dirty tricks to keep a temp table around are absolutely okay. I mean, you could even use, and now I'm probably getting kicked out here. You could also use shared temp tables on and PaaS-OE.
I will.
The
fake. I didn't hear that. No, that's
the challenge with temp tables persistent is that, remember, in PaaS, the one process, the one set of memory, you're going to have many. If you have like whatever the default is, 200 or 100 sessions in PaaS, whatever you're putting in your temp table caches gets multiplied by the number of sessions you have. And so your agent process memory grows and is also not really often given back to the operating system. And so if you're not careful, you run the risk of things like Linux's out-of-memory killer coming along and killing the agent process. So it's just another factor to the cache versus temp table. The database versus temp table thing is that aspect of it, that at some scale in PaaS, you have to be careful that you don't bloat the agent processes memory too much, which you do by X times on the sessions.
Yeah, okay. Thank you. And what was the secret hidden log manager entry type for temp tables?
Temp minus tables. It is the, let me see which. In one of them.
It's only document. Oh, okay, temp tables. Okay, thank you.
So in my defense, it is not in the online help of the log entry types attribute.
No, exactly.
So I actually only learned about it this morning when Peter told me about that. And it is in the documentation. And right after this webinar, we will log a bug with Progress Software to fix the online documentation.
Yes. Very good.
All right, then.
Good. Well, then, thanks for your time and interest. And talk to you soon. Bye-bye.
Ciao.
Thank you very much. Very interesting.